Good morning, everybody. I think we're ready to begin. Thanks for joining us again at our Cleantech in Canada breakfast, sponsored by Ogilvy Renault, Deloitte, and Mars Discovery District. I'm Rick Sutton of Ogilvy Renault, and I'll be moderating today's panel. This is, believe it or not, our 11th breakfast, and the interest in our topics does continue to be strong. And just before beginning, I want to again acknowledge the work of all the people at Ogilvy, Deloitte, and Mars who worked together to pull this together with topic and panelist selection, background information, invitations, logistics, and food. It's a great team. Now, today's topic, while sexier technologies such as solar, wind, and electric cars tend to draw a lot of attention, waste management and recycling is really the low-hanging fruit of the clean tech sector. It solves immediate problems, it's out there, it's profitable, and there's many, many opportunities. So this morning we have a panel of industry experts to enlighten us with their views on the state of the industry and some of the opportunities that are out there. First of all, I will now go in order from me over that way. Pushkar Kumar is the CEO of Green Mantra, an emerging Toronto-based clean tech company that has a proprietary technology developed in India and being commercialized in Canada that involves the complete recycling of waste plastics into new products, primarily waxes, oils, lubricants, and greases of various grades for primarily industrial use. Green Mantra is an early stage company, Pushkar will tell us, just received their first financing round, and it also is a graduate of the Mars program, which is nice. And they're currently looking at establishing up to 3 locations in and around the Toronto area. Our next panelist is Jeff Rathbone, who's General Manager of the City of Toronto's Waste Management Services. Toronto is Canada's largest city, and it's the 5th largest in North America. Jeff conducted, over the last few years, a comprehensive review of diversion systems, including new and emerging mixed waste treatment technologies for city, as the part of the design of what they call their Target 70 program, which is to have 70% diversion of the municipal waste. So he's going to share some of the findings from that study with us today. Next is Alan Evans. He's a partner in a Canadian company called EnviroPure Systems, which has a revolutionary patented food waste elimination technology that allows organic food waste to be processed on site at the source where it is generated. This is a self-contained system that eliminates food waste within 24 hours with no odors, sludge buildup, or significant cleaning, and allows companies to help reduce their CO2 emissions and overall carbon footprint by eliminating the environmental impact of pickup and transportation of their food waste to landfill or composting. The system significantly reduces garbage disposal costs, the byproduct is compostable, and the effluent water meets municipal codes. Their technology is quickly gaining acceptance with clients like Hyatt, Sheraton, Four Seasons, Westin Hotels, University of Nevada, the New Jersey Department of Corrections, Providence Hospital, and Scarborough Golf Club in Toronto, already using the EnviroPure system to handle their organic food waste disposal needs. They have 15 units installed or in the process of being installed in Canada and the US, and expect to double this over the next 90 days. And our final panelist is Richard Fish, who's the president of Alter Energy, a Calgary-based publicly traded company providing leading clean energy solutions offering plasma gasification technology and geothermal energy. The most interesting for us is the plasma gasification technology, which was originally developed by Westinghouse. It's been around for about 20 years, I believe. And Richard's company is currently advancing 23 projects with this technology in Canada, the US, and around the world, and including a proposed waste energy project in Dufferin County, just north of Toronto. Alter Energy will be cash flow positive this year and has expected revenues of $30 million. So, now to our discussion. We decided to break down today's discussion into 3 sections: landfill, diversion recycling, and thermal, which is really the term for using waste as a feedstock for energy generation and what people who don't support it call incineration. So let's start with landfills, and maybe we could start and ask Jeff to just give us a little bit of a brief story of Toronto's dance with landfill over the last few years.
Okay, I'd be happy to. The story actually begins a little bit before my time. The City of Toronto is about 175 years old, and during those 175 years, up until 2002, the city always had the capability of siting a landfill within our jurisdiction, within our boundaries. And in fact, there's probably about 130, 150 closed landfills around the city that we still have the long-term responsibility for, the perpetual care responsibility for. However, we hit a wall in 2002 when we were unable to site another landfill in the Greater Toronto area. And you may recall the debate about Adams Mine and many different alternatives. Ultimately, when the Adams Mine proposal did not go forward, really the only alternative available to the City of Toronto was to ship our garbage to a private landfill in the state of Michigan. So between 2002 and 2010, in fact only 6 weeks ago we stopped, we were shipping our garbage, all of our residual garbage, to a private landfill in Michigan. And at our peak, we were shipping about 140 tractor-trailer loads of waste every day to that site. And much to the chagrin of the state of Michigan, who attempted in many ways to put legislation in place to stop our garbage from going there. That really created a situation in Toronto where we became very aware of how vulnerable we were in terms of disposal security. We were sending our waste on a 12 to 14-hour trip, 140 trucks a day, to a jurisdiction that did not want our material. And when we did see any kind of disruption at the border, 9/11, SARS, it caused an immediate backup. And we only had about 48 hours of storage capacity in the City of Toronto transfer stations. And if the border was closed for longer than 48 hours for any reason, we really had nowhere to go. So you can see that disposal security then really became, for the first time in our history, a really, really important element of our waste planning. So when we decided that Michigan was our only option, Council also simultaneously directed staff to attempt to divert 100% of our waste from landfill. We ultimately came back and said we can't technically get to 100% diversion, but we think we can get to 70% diversion from landfill. Or to put it in round numbers, we generate about 1 million tons of garbage in the city per year. So that would mean that we would only want to landfill or send to final disposal about 300,000 tons. So over the last 8 years or so, you've probably seen rapid growth in many programs here in Toronto. The rapid expansion of the blue bin and now, or blue box and now blue bin program, certainly the green bin program for kitchen organics. Most recently, we've been tackling the durable good sector with electronics and furniture, mattresses, ceramics, all being recycled. So we've made great progress over the last decade, moved to about 47% overall diversion. So we're now sending a little more than 500,000 tons of material to landfill. And our goal is to squeeze out another 200,000 tons of diversion to get it down to that 300,000 ton number. So that sort of sets the context, I think, for where we stand today, and we're continuing to work on these diversion programs. The next big one that's on the horizon is a pre-treatment facility prior to landfill that we're looking at building, what we call a mechanical biological treatment facility, or a mixed waste treatment, that would take all the garbage that has already been source separated by our residents to a great extent, and then attempt to squeeze out the final organics and recycling prior to going to landfill.
So I think the stage is sort of set with the theory being to try to deal with the majority of the problem through diversion/recycling. And I think so that sort of leads us into the next section, but it also raises a couple other issues. The first of all, as Jeff has told me, the city is only responsible for residential and small commercial. Larger commercial and industrial have to deal with their waste disposal issues through private sector means. So the missing piece of the puzzle here is of what you do with those. And I think some solutions like Alan's company, which goes to these people and says, I've got a private sector solution for you that's economic and that that is more attractive than, having to squeeze ourselves into the city's landfill issues and everything, is something that would be very welcome by everybody. So, Alan, maybe you just want to talk a little bit about your system?
So, EnviroPure systems are essentially a self-contained, small footprint, organic food waste decomposition system. They're designed to sort of deal with the industrial, commercial, and institutional sector food waste, primarily commercial and institutional kitchens, by processing the food waste on site at the source when they generate it, rather than trucking it away to landfill or to composting, even large-scale composting sites. We've got two types of systems. There's two technologies, essentially a wet system and a dry system. The wet system, the decomposition takes place in a submersed chamber environment and produces a gray water effluent that it can be disposed safely and meet standards for disposal into municipal wastewater systems. The dry unit is a substrate-based decomposition system that basically gets about 1,000 to 1 all the way up to 1,500 to 1 compression. So for every metric ton of food waste that you put into the system, you get 1 kilogram of byproduct out the back end. And that byproduct is a nutrient-rich compost that can be used in agricultural or landscaping applications. How the system works, it's essentially a combination of mechanical processing, so that the food waste is agitated in the reaction chambers, in conjunction with maintaining the environmentals of the system. So we maintain the temperature optimally, the amount of oxygenation of the environment, as well as the pH. And then there's a biological additive that we have in the system that actually accelerates the decomposition. Now, there's a number of different ways you can do that. There's enzymes, bacteria. Our additive is neither of those. It's actually a mix of nutrients, minerals, amino acids that are absent in the food waste, but that the bacteria that already are on the food waste need to do their job. So we provide that. It results in the bacteria population proliferating massively, drowns out the bacteria that actually cause the smell, the sulfite-fixing bacteria, and you get this sort of self-reinforcing cycle that results in the food waste being pretty much eliminated within 24 to 48 hours. Capacity-wise, the systems have a number of different capacities, ranging all the way from 2.5 kilograms, which would be a home-based unit, all the way up to 2.5 metric tons, and that's the processing capacity per day. And the economics of that processing capacity are really attractive. So, I mean, as most of you know, you go out to landfill, it's depending on where you are. If it's a subsidized environment where stuff's being shipped to composting facilities, you're talking anywhere from $35 to $50 a ton. In unsubsidized areas where the stuff's going to landfill, it can range all the way up to $100, $150 a ton. Whereas our system, we can get it down to the sort of $25 to $50 a ton, depending on the size of the unit and the configuration of the unit. So economically, it's very attractive to customers. The other part of the economic equation, I guess, is the capital investment. It's not the upfront capital investment for the system isn't very substantial, so we get, typically customers realize a fairly quick payback of 18 to 36 months payback on the system, and then obviously fairly strong ongoing return on investment over the life of the system. So, not only economically and operationally does the system provide benefits, but I mean the obvious ones are the environmental at a good economic proposition, right? And that is, we're no longer sending organics to landfill where they generate methane, which is horrible for the environment as a greenhouse gas, but we're also eliminating the greenhouse gases that are generated and actually trucking the stuff and picking it up, as well as all the wear and tear, congestion. So, in conversations I had with Jeff earlier, that's obviously something the city is very much interested in assisting, sort of getting that type of technology in place for commercial and institutional. So we think it's a pretty good value proposition for our customers and for the environment and for the city overall.
just I think you said they start at about $30,000 a unit?
Yeah, I mean, the 2.5 pound a day unit isn't anywhere near that. It's sort of the more $1,000 range. But when you get, for the economies of scale, you need to make it really worthwhile, and the type of customers that we're initially targeting, yeah, it's probably $20,000 to $30,000. You know, at a really high end, doing, you know, 2.5 metric tons a day, it's about the $30,000 capital investment. Yeah.
And for those of us who walk around the city in the summer, this would be a welcome improvement, as if you make the mistake of walking behind the hotel instead of on the front side. Well, I think this is, you know, I think the natural progression of this discussion is to move into the diversion recycling area, because that, actually, just before I do that, Jeff, is there a plan to build methane capture technology at Green Lane in London?
Yes, there is. In fact, we generate significant amount of gas at the landfills. Some of our closed landfills currently have generation facilities that basically put electricity back into the grid. At the Green Lane facility, we're looking at a really innovative approach, because simply creating electricity is a good thing, but is not extremely efficient. It's the waste heat from that creation that you also want to capture. So in the case of Green Lane, we're working with a company, Ontario Plant Propagation, which is just south of the landfill. It's probably Ontario's largest greenhouse complex, commercial greenhouse complex. So we're looking at actually piping the gas to the greenhouse complex, at which point it would then be used to create electricity, and then the waste heat from that creation can then be used in the greenhouse. And what also is really interesting is that plants need carbon dioxide. So the carbon dioxide that's also a byproduct of that combustion can also be utilized within the greenhouse. So it's an exciting project that is just basically waiting for its FIT approval.
Well, I'm going to continue with you, Jeff, because I think now I'd like to turn for you to give us a little summary of the city's study.
Okay.
And I think there's a couple of slides that will help.
Great, if you could.
Is that the right one, Jeff?
That's a good start, I think.
Okay. Clear as day, eh?
Yeah, hopefully it's clear as day. I don't expect you to read all the words. I'll lead you through what this is basically saying. Maybe 3 to 4 years ago, we started the process knowing that we did not think we could get to 70% diversion from landfill with just source separation techniques, blue box, green bin, leaf and yard waste separation. That can get us into the mid-50s, but if we want to get that additional 150 to 200,000 tons of diversion, we need to actually treat the waste before it goes to landfill. So we put all the technologies on the table, full range from mechanical, biological, chemical, thermal, basically all technologies on the table. We also have a citizen group that assists us with this process. We simultaneously then looked at all of the process technologies and siting options, and then gradually used screening criteria to ultimately decide on what we have decided to go with, which is mechanical biological treatment, which would be built near our Green Lane landfill. And one of the criteria that we looked at was, what is the definition of waste diversion? Because we wanted to ensure that if we were going to build a facility that was working towards our diversion goal, that it actually aligned with the Ministry of the Environment's definition of what is waste diversion. And the Ministry has a policy document that's out, and in fact it was meant to be for the ultimate revision of the Waste Diversion Act, which is still underway but is a little bit stalled right now. But what the Ministry's laid out is that there's really 3 types of waste systems. There's systems that prevent waste, such as the 5-cent bag fee on plastic bags. There are systems that divert waste, Blue Box program being the classic example. And then there are systems that dispose of waste, if you like, final disposal. And basically the line that's drawn between diversion and disposal is the tricky line. and what the ministry from a policy standpoint, and which ultimately affects the permitting and ultimately affects which systems need to go through environmental assessment processes, disposal, and which systems do not need to go through environmental assessment processes, diversion systems. And you can see that the line basically puts both landfill, even with excellent gas recovery systems, and thermal technologies, even with energy recovery, in the disposal category. So that was an important consideration for us in that, again, if our goal was to move to 70% diversion, we had to look at systems that were classed as either prevention or diversion. We also looked at timing, because if we want to keep the key reason for our diversion programs is to make our landfill last as long as possible. And therefore, we need the diversion sooner than later. Sort of like an investment, you need to make the investment early if you want the returns. It doesn't do us a lot of good to have our diversion system coming online near the end of the life of the landfill. And if we had to go through a full environmental assessment process, that would take probably 7+ years from inception through turning the key. And the final consideration was that we had just acquired the Green Lane landfill, just released ourselves from the long-term future liability of disposing of waste in Michigan, and we wanted to ensure that any residual waste that comes out of the facility, mixed waste treatment facility, would be able to go to our own disposal facility. So as we looked at those three criteria, we narrowed the field and ultimately chose this mechanical, biological treatment for our waste, as opposed to the other technologies that we considered. And
Do you want to move to the next slide?
Sure, we can just move to the next one. Again, I don't expect you to see this fully, but what it's basically saying is that on the top, we currently manage all the residential waste from single and multifamily homes and from all the city facilities and from about 20,000 small commercial customers. All of those customers have access to all of our source separation programs, blue box, green bin, et cetera, electronics recycling. And whatever waste is then remains then goes to our transfer stations and ultimately goes to the Green Lane landfill. What we're proposing is that we continue to put our emphasis on all the source separation programs, but then instead of just going to landfill, the material would go through this treatment facility, and we'd actually look at adding biosolids from our wastewater treatment plants to the mix as well. And then at that point, we would mechanically pull out recyclable materials, obvious things like pallets or scrap metal. And then the remaining material would be anaerobically digested, where we'd capture both a lower grade compost than we could capture through green bin, and we'd capture biogas as well, which could also feed into this landfill gas system. And ultimately, for every 100 kilograms of material that we put in the front door of the facility, only about 50 kilograms would ultimately go to landfill. So that basically, by adding this final step, it gives us about another 8 years of capacity at the Green Lane landfill, moving us from a closure date of 2026 to a closure date of 2034. So that's a quick overview.
Thanks. Oh, you might be interested to know that the city considers the what they call the self-separation, I think they actually refer to it as the free labor that takes place at the household. All right, so obviously diversion and recycling is a key component, and maybe Pushkar, you can tell us a little bit about your technology and how you fit into the system. Like, you know, will you be sourcing materials from the city, from their Blue Box program, or will you be sourcing from industrial users, or from both?
Yeah, thanks a lot. So my company and the technology is relatively new, very new. We just incorporated in 2010, January. Now we have reached a stage where at least I can say the plans are on place for us to expand and put our first facility. So the technology is about producing the same old waxes from a new source material. The source material in our case is the plastics. Currently focus is only on more post-industrial plastics. We can also pick up a plastic from blue box. The idea being, it's always risky to start the new operation with highly impure plastics. So wherever there is more purity available in terms of post-use plastics, we go there. The dream is, of course, the 5-year, 10-year vision is to be able to pick up all the plastic waste, which I can pick up, and hopefully 100,000 tons, which is there, but that's a dream. So the first year capacity, which we are looking in terms of transforming plastic, is not more than 240 tons of plastic a year. We are also initially focused on only few streams of plastics, not all polymers. We are only looking at a hard HDPE plastic or shrink wraps, which are LDPE or LLDPE. Which in your understanding, that means things like shrink wraps, plastic bags. But of course, we prefer to pick up things initially from a much more pure plastic source, like post-industrial in the initial. It's expensive, but that's where the risk is less. Now, good thing is the product which we are going to produce is a wax, which is highly scalable industrial use product. Like in North America itself, it's over $2.2 billion commodity, gets used literally everywhere from, think of it, easiest is candles, then you go in terms of understanding in polishes. It's a key ingredient for shoe polish, wax, car polish, or anything. In fact, the chewing gums that you chew is 60% waxes. Then you have cosmetics, paints, ink industries, everywhere. So good thing is if the process starts succeeding, then we will be able to pick up a lot more streams of plastics, maybe more impure plastics, and since the process is scalable, the demand is also, it's a commodity product, demand is also there, we will be able to pick up a lot more plastics. So that's our process, and hopefully we are able to work together.
And your first plant will be operational?
See, the system, the basic technology on which the process is built up is relatively simple. You just think about get source in the plastic, melting it, putting our proprietary catalyst in it, and in next 2 hours or so, you get the waxes, which we then filter and produce and sell. So the equipment which is required is relatively small and can be produced in 4 to 5 months. So we are looking to have our first facility operational in and around Toronto in next 6 to 8 months or so. So that's our plan. So hopefully by then we'll have enough orders also.
Okay. Well, I think that, even with the diversion, there's still 30% that is earmarked for landfill, and there's been a debate for many years about landfill versus thermal or incineration. And Richard seems to have one of the leading technologies in this sector. So maybe you can just give us a little overview of your plasma gasification technology and where you are in the marketplace.
Okay, thanks. And where we fit is we're just another piece of the puzzle. I think as Jeff pointed out, I mean, there are some big numbers going into what you've got in just the local Toronto market, and on a larger global basis, hundreds of millions of tons of garbage being landfilled on an annual basis. So how you tackle that one is not with one silver bullet. It's going to be a number of different solutions that will take care of it. What do we do? Simply put, plasma gasification, we're an advanced thermal treatment. Alter actually owns the patented Westinghouse plasma technology, and by using plasma torches, which were actually developed back in the 1960s for NASA to test the heat shields of reentry vehicles. So they generate some fairly high heat, up to 10,000 degrees C. We effectively use the plasma torches with a gasification process to take really any waste-based carbon material and turn it into some type of useful energy. And that useful energy can be power. Even, Jeff, you were mentioning things like waste heat, and those are some interesting things that we can also do. Use those byproducts to power our provide heat for greenhouses, et cetera, but also liquid fuels. So it basically takes any carbon-based material, breaks it down into a base form, carbon monoxide and hydrogen, and it's a fundamental building block. You know, how we fit in, particularly versus just regular versus earlier incineration, because of the temperatures produced and our ability to break things down to a more molecular structure, it's environmentally cleaner. Not zero emissions, but an environmentally cleaner process, also more efficient. And through that efficiency, again, it would lower some of the cost to produce either power or liquids. And I think that's probably one of, again, the other things as to where any of the technologies fit. You know, it's very easy to be environmentally friendly when it's economic. And, you know, one of the things that we've worked on, you know, in terms of moving the technology further along is to be able to reduce the capital costs to make it economically viable. Our technology has been in commercial operations now for about 10 years. Unfortunately, none of the facilities are in North America. We have a pilot facility in Pittsburgh, Pennsylvania, which actually takes biomass, wood chips, feedstock, produces synthesis gas and feeds that to a biological reactor that produces ethanol. So that's a pilot demonstration facility. But otherwise, our facilities are in Japan, India, and 2 facilities coming online in China this year. Our process would produce baseload power. And if you were looking specifically in power, why that's important is regardless of what we're doing with waste, you know, we're facing global power needs. So how can we convert waste products into power is, again, another piece of the puzzle. Where our technology can also fit, and I think it's in conjunction with good diversion programs, is that we can handle the stuff on the back end. If you're still going to landfill 75,000 tons per year or some number, you know, your ability to still convert the carbon content of that into some other usable product in an environmentally responsible way makes a lot of sense. If you look throughout Europe, different parts around the globe that have been very successful in reducing their landfill use to under 5% of their total waste generation, thermal treatment is part of that puzzle. So you know, it's a combination effect, and you know, when you start to look at just how quickly, for instance, to divert to, you know, get to 50% is a great number.
You mentioned that there are some emissions, and I think, Alan, there are probably some emissions from your system, although I don't know for sure. Does anybody know, have there been any authoritative studies on comparing the overall environmental impact of thermal to landfill? Because I know your emissions must be, what, some carbon and maybe some dioxins or something like that?
Well, the dioxins and furans are, you know, essentially removed. Okay. And there are a lot of, it's one of the things of having a commercially operating plant for almost 10 years now in Japan, a lot of statistical data. We compare those back against, since we're a North American company, Canada, U.S., going through U.S. and Canadian regulatory, compare against, you know, environmental protection mandates. So we're, you know, not only below, but well below any of the standards. But again, you know, there are emissions, and I think that's, you know, kind of one of the things from a responsible standpoint. Again, there's not a, you know, a perfect solution, and unfortunately, a lot of times, what happens with regard to thermal technologies is it's either, it goes to one extreme or the other. There are no zero emission thermal technologies out there, and, you know, not all of them are, you know, releasing, you know, harmful levels of, you know, emissions, you know, into the air. I mean, it's, there's a balance in the process.
Is there a reason why you don't have any in North America? Is North America not psychologically ready for them yet? Is that it?
Well, it's a very slow process.
Yeah.
Projects of these types, can easily be 5 to 10 years through the permitting phase. Currently, within North America, we've got one that's just exited and received a U.S. Environmental Protection Permit in Florida. That was almost 4.5 years in the process to get just through the environmental phase. So there was the glacier age, and then there's kind of moving through the environmental process, but that's with its merits.
And is there a use for the residual ash?
What comes off of our process at the end is there is going to be something landfilled, but we can typically take, for instance, metals, different things that still aren't picked up in any of the other sorting or diversion processes are captured in a molten slag. They're inert. It becomes kind of a benign aggregate that can be used in cement, landfill, etc. Is a small amount of ash that's actually generated depending on the type of feedstock. We've been working and actually have patented a process to take that and recover that ash back, because it does have some carbon content, back into the gasifier. So, just even within our process, we're working to kind of, have further efficiencies to further reduce any need to ultimately end in that landfill and maybe extend it out another 5 or 10 years.
And obviously you've satisfied yourselves that they're economic. I'm wondering how would you compare your technology with the Plasco technology, and that seems to have had a lot of excitement for a short period of time, and we haven't heard from them for a while, so one has led to the suspicion that maybe it's not as economic as they originally thought.
Well, and we want them to be successful. They're a competitor of ours, but and the technologies are different. We have a very simple one-stage process, is the Westinghouse process. Plasma gasification is definitely not an economic solution on a broad scale, for every circumstance. It is going to be a combination of things, where tipping fees, for instance, would fold into that. Power prices in the local market if you're generating power or liquids. But on a installed per kilowatt basis, if you kind of look at plasma today, on average, it would be, versus other thermal treatments like a typical incineration facility, about the same, actually a little less than a nuclear facility. Wind and solar, you would have, depending on the application, would be above or below. Again, the difference is, wind and solar are intermittent. They cannot provide base load power, which 85% of our power needs in Canada are on a base load basis, and when we're looking at those kinds of solutions, how we feed into those, are going to be the key. So we spend a lot of time from a client base and working through each of the solutions to understand the economics, how they fit, and again, it's in part with the diversion programs and really what are developing into small eco parks. That's really how thermal technologies, I think if you look in the next 10 to 20 years, they will be part of kind of an eco park solution.
Which would include organic processing facilities?
Anaerobic, MBT, right. All the other diversion pieces, heat recovery, blending with the landfill gases.
They could actually combine to become a bigger power source if they were all oriented towards producing power.
Correct. Yeah. And there are even, because again, what do we produce? I mean, if you want to look at some of the 10 or 20 year things out there, being able to take the hydrogen streams for fuel cells.
Right.
All of those things become, possible. It's just a matter of, can you do it economically? And that's not a matter of if, it's just the when.
Right. So Alan, you said your technology is zero emissions. Maybe you can tell us how you got to that, and maybe you can talk about how scalable it might be.
Sure. So I guess it's a bit of maybe a misnomer to say it's got zero emissions. Obviously, I mean, the byproducts of the process are primarily water, which is the composition of food to start with, and CO2. But the CO2 is biogenic. It's CO2 that's returning to the environment from existing carbon that was fixed in the environment by plants or animal sources. So from Environment Canada, not Revenue Canada, but Environment Canada and the EPA in the U.S., it's considered biogenic and net neutral to the environment. So when I say it's, there's no emissions, that from that perspective, it's zero emissions. Scalability, we currently have the ability to scale to about 2.5 metric tons on site. It really becomes a size issue for on-site processing because it all comes down to displacement in terms of the volume of food going into the wet unit, definitely, and in the dry unit in terms of the amount of airflow across the system in terms of a lot of the water components of the food in the dry system are evaporated off as H2O gas. So it's definitely scalable. I mean, theoretically, you could envision a huge ethanol-sized type plant doing this, but right now, I mean, that requires some pretty additional R&D investment and work, right? Partnerships probably to get there.
So Jeff, for a lot of this series we run is to give people some insight into some opportunities, some new technologies, some new ideas. It sounds to me like, first of all, in the new regime at the city, I think we all know that there's more of a sense of welcoming a private sector participation. And it looks to me like all the other three co-panelists are potential partners with the city in solving our overall waste issues. And do you see that I know that's hard for the city to sort of decide who they're going to pick and choose, but do you see this as creating some opportunities going forward that rather than have a philosophy of go it alone, you would see yourself partnering with private sector-led technologies and facilities?
Sure. So first of all, just to set the context, because I think there is a perception that in the City of Toronto we tend to primarily use our own staff to manage facilities. But when you look at the overall dollars spent on solid waste management within the city, currently 51% of our dollars are spent on contracted services, and in fact some of our contractors are here today. 49% of our dollars are spent on services provided by the public sector. So especially behind the scenes, our green bin processing facility, our landfill, our recycling facilities are all operated by private companies. So we certainly welcome the notion of bringing in private expertise. And as we move forward with the mixed waste facility in the vicinity of the Green Lane landfill, we'll actually be having a competitive bid process that will offer two alternatives. One alternative will be for a company to design and build and operate a plant that we would own on our Green Lane buffer lands. We own about a 2-kilometer zone around the Green Lane landfill. If I didn't mention, Green Lane landfill is just west of London, maybe 6 or 8 kilometers west of London on the north side of the 401. The alternative there is that we would simply say, alternative B is that we'd simply say to private companies, we will guarantee our tonnage to the facility, our tonnage of municipal solid waste and biosolids, and we'll leave it up to you to design what the black box is within these parameters. And we'll leave it up to you to put the capital in, and we'll simply pay a tolling or tipping fee. So we'll simultaneously look at both options and make a decision once we see how the bids come back.
So Pushkar, are you going to go and pitch these guys to sell them your...
Oh, definitely. 2 years down the line,
stuff?
yes. Blue Box is actually a very interesting program. It produces the right kind of plastics, it captures the plastics directly from the source, and good thing is also it's relatively clean for anybody else to pick it up and use. So one of the options which I'm evaluating is definitely Blue Box.
Great. And on that one, on the Blue Box, you don't have to wait a year or two until we put the tender out on the mixed waste facility. We already generate the high density polyethylenes, the low density polyethylene, and other plastics that we actually tender on a regular 6-month basis. So you're welcome to be on the bidders list for those.
Yeah, thank you.
If these get really valuable, they might come and pitch you and say, look, we'll go and pick it up as well.
Well, the interesting thing is we actually, recycling is the one area where we actually make money as a city. It's less expensive for us to recycle because of the value of the commodities. We get, on average, about $130 for each ton of recycling that we collect. And we also receive contribution from the brand owners of the products that go into the Blue Box system. So the Procter & Gamble's and Crafts of the world, Kellogg's, they pay 50% of our municipal Blue Box costs. So between those two factors, even though it's generally more expensive to collect recycling than collect garbage, on a net basis, we make money on recycling relative to disposal, and therefore we want to get every last kilogram.
And I wanted to go back, Alan, on, is the technology, your technology, I mean, is that roughly similar to the kind of organics technology that the city might be using at, on a bigger scale? Are we talking about the same sort of general area of technology?
To be honest, I'm not really sure what the biological component of the city's
Wet
solution.
AD.
Okay,
Wet anaerobic
so
digestion.
anaerobic digestion. So ours is aerobic, essentially, right? We go to great pains to make sure that there's sufficient oxygen to have solely aerobic digestion. I mean, without getting too technical, the system actually fluctuates back and forth rapidly between anaerobic and aerobic, essentially, because aerobic generally generates sludge, which our system doesn't. So the sludge is sort of consumed in the anaerobic phase, and then very quickly snaps back to aerobic, and then that prevents any of the anaerobic emissions, the methane. So,
actually, one thing that I didn't mention about yours, I don't think you did either, which is that the residue, other than the water which goes into the regular water sewage system, the residue, which is compostable, only has to be emptied, what, every 6 to 8 months?
yeah, in the larger system, so a system that's processing, a ton a day, a metric ton a day, would typically go for 6 to 8 months before you back out the compost. And the compost is, like I said, 1,000, anywhere from 1,000 to 1,300 to 1 in compression. So you really only get maybe 300-400 pounds back out of the system.
And it's odorless?
Yeah, that's kind of one of the key things, right? I mean, so the dry systems are fairly large, so they typically end up being positioned outside a facility with a chute to feed them. The wet systems often end up in the environmental area of the basement of the facility, and we pump the slurry down into it. The wet systems, because it's submerged, you get zero smell. And in the dry system, because you're pumping so much air through and it's all aerobic, and the aerobic bacteria just explode, drowning out the sulfide-fixing bacteria, you get no smell as well. Yeah. So that's kind of one of the key things, right? One of the big operational problems that it solves, because not just the odor, which is, from employee perspective, but also the neighbors, for grocery stores, you don't get too thrilled about that sort of stuff. But also bees, pests, vermin, rats. I mean, there's costs associated with controlling all that stuff, as well as just the sheer nuisance factor, right? So that's one of the biggest sort of factors that our customers are keen on.
Jeff, what if any levers does the city have on the commercial and industrial sector if you're not responsible for their waste disposal? I guess tipping fees and things like that can push them in directions you want to encourage them to go, I guess, eh?
Yeah, I think I mentioned earlier that we do service about 20,000 small commercial customers. So if you're driving Queen Street or Yonge Street, you'll see restaurants and small retail establishments that use our use the same program that's available to the residential sector. Right. They have access to the same Blue Box program, Green Bin program, et cetera.
Curb pickup.
And then they pay based on the amount of garbage that they produce. But you're right, on the larger facilities, First Canadian Place, they're managed by a private company and really subject just to provincial Ministry of the Environment regulations.
And cleanliness, whatever, bylaws.
Sure, absolutely. And we certainly would encourage them to, if you like, challenge them to meet the same goals that we're attempting to meet as a city.
Right.
But because their material goes to private landfills, it's just not directly within our responsibility.
Right. So these source solutions for some of their waste could be, would obviously be welcome.
Absolutely. And we also allow our contractors to piggyback on commercial material to bring the total cost of the system down. So by allowing our contractors, if we said you must use the facility strictly for our material, it would generally mean a higher cost, but by allowing some private material in, it lowers everyone's cost, and it's a win-win.
Okay. Well, before we turn it over to the audience for questions, anything the panelists want to say that they haven't had a chance to say? All right, if any questions, there's a couple of mics, so if you're probably best if you got a question, if you walk up to a mic.
Yes, the question to Jeff. Jeff, just now you said City of Toronto landfill cost is $130 a ton. And for Blue Box program, manufacturer donate or maybe manufacturer pay 50%, $65 to a ton to City of Toronto, correct?
Not quite. I think hopefully what I said was that the value of the recyclables that we collect, on average, what we call the basket of goods of recycling, newsprint, cardboard, all the plastics, glass, et cetera, on average has a value of $130 per ton. And what the producers pay is 50% of our net cost of recycling. So it costs to collect, to process, minus the revenue from sale of material, the $130 a ton, gives a net price of approximately $100 a ton, and then they pay 50. So our net cost of recycling is significantly below $100 a ton.
Oh, okay. So the second question is, after sorting the MRF, like number 1 to number 7 commingle bottles, so normally I believe the number 3 to number 7 commingle bottles may be landfill. So I just wonder, City of Toronto support waste into fuel. I say using pyrolysis system change the landfill material into diesel and gasoline. I'm not sure, if City of Toronto support this kind of technology.
I think in general what we would support would be to first exhaust every possibility of recycling the material into a beneficial physical product. There's always, from a hierarchy standpoint, we would always look to recycle similar to the ministry hierarchy rather than strictly looking for an energy value. So for example, right now, and everyone in the room would know that we're seeing an explosion of what we call thermoform plastics, which are the hinged containers. You would get salads, candy, or with a plastic lid. It's a product that we currently do not have a market for, but when we do our audits, we know that people are already assuming we do have a recycling market and they're putting it in the blue bin. So we are working with a company in Sarnia and a company in Elmira to recycle those plastics. We're part of the pilot in the province, and it's looking quite promising for us to be able to add those plastics to the blue bin. So that would be an example where if we simply move to an energy solution for those plastics, it would then preclude the possibility of finding a recycling alternative. But there may be some plastics, and we haven't given up on any yet, such as chip bags, potato chip bags, et cetera, where we will never find a market, and we might then look at more of an energy recovery.
I think there's a question over here.
Yeah, I have another question. I guess it's addressing the City of Toronto over here again.
Thanks.
So I wonder what you've been seeing with respect to amount of the blue bin waste since you've introduced those new containers, because I wonder how you factored in the change of the behavior of the citizens of Toronto. And I'm asking this question is, I've lived for 10 years in Hamburg, Germany, where they have invested lots of money into improving their technology of incineration in order to reduce the emissions of toxic substances. And so they had optimized that, and there were virtually no emissions anymore. And then they introduced the recycling system, And Germans recycle really diligently, so they really separated everything. So what happened was that the residual waste that went into incineration was so low in energy that they, without telling the citizens, started reintroducing the high energetic plastic into the incineration to keep the process going. So this seems to be a very, intricate system that needs to be balanced. And I wonder how you've factored in change of behavior of the people that do the recycling, and if you do see that they recycle more diligently.
Thanks for the question. So about 2 or 3 years ago, we put in place, I would say, 3 factors that have had quite a dramatic impact on improved capture of recycling and also green bin and other materials. We established basically converted ourselves from being a city division, like parks, into basically a solid waste utility, more like Toronto Water. So we're now a completely self-funded business unit, both operating and capital. And coincident with that, we also, of course, established basically a pay for the amount of garbage you produce system for the residents as well. So residents now pay between $200 and $400 per year, depending upon the size of bin that they choose. So that economic driver has both given us the revenue we need to have diversion programs and also has had a significant impact on behavior. We also, as for those of you that know in Toronto, we made it even more challenging to produce garbage by reducing the frequency of garbage collection to once every 2 weeks. And I guess finally, we've attempted to make recycling as easy and diversion as easy as possible. So where we've seen a very dramatic change is in the multifamily. Prior to the introduction of the utility program, the pay-as-you-go program, apartments and condominiums received free unlimited garbage. And you can imagine what that did to our diversion programs. So now that buildings are paying for the amount of waste they produce, again, dramatic increase in diversion.
Yes.
I have one quick question for Richard from Ultra Energy. And by the way, my name is Lily, and we emailed us several times.
Okay.
And we have some Chinese companies looking for plasma technology, and they have quite question because they know plasma is also very power consuming, and compared with the power from the incineration, it generated how much percentage of energy has to go to plasma to support plasma, and this will affect the economy of this technology using in waste management.
Mm-hmm. Great question, and it's again the economics is what's driving a lot of the processes. So at a very high level, if you look at kind of an energy balance piece, about 80% of the energy from any of the feedstocks, whether it would be municipal solid waste or an industrial waste that was fed in, would be converted or would be usable. About 20% of that goes back into the operating side of the business. That would be between the plasma torches, running the pumps of the facility, entire facility piece. Plasma as an overall percentage, is very small. Think of actually the plasma torches within the larger gasifier. They're almost like thermostats. They don't actually need to fire all the time. They're regulating heat within the reactor chamber. Once temperatures are above 1700 degrees C, you've really achieved what you need to do to vaporize the material. So they're not running all the time, and that's, I think, one of the things when you fire off one of these things that looks like a jet engine anyway. There's a misconception of the amount of power that is consumed, but there is power consumed. It's going to be 3 to 5% of probably just the operating aspects of the facility itself. And typically, when we go through any of those to sit down with a client, we can show them what those operating expenses would be.
Hi, my name is Joe. I'm a student from University of Toronto. I in a group of 3-4 students like to about 2 years ago, did a preliminary sort of research study project on waste treatment, and we kind of look into the plasma gasification technology. So I have a question for Mr. Fish, kind of similar to the previous question. That I just want you to sort of comment on the advance of this technology, on the impact of that on economics per se, and also the stabilities of the torch and other part of the system. Mm-hmm. Thanks.
Okay. Well, as I said, the genesis of the technology goes back over 30 years with Westinghouse. And the facilities in Japan have now been operating will be going into their 10th year. So even since the Japan facilities were opened, there have been generational changes in the technology, as there are with laptops and everything else. Really, our biggest focus has been more in the design characteristics of the gasifier itself and allowing greater residence time of materials within the reactor to get a much more efficient processing of the material. That and capital costs. As our companies continue to mature, we've continued to source on a global basis to help reduce the costs of the overall equipment. We've become more efficient in the process, and as a consequence, capital costs go to the overall economics of the project. So those are the combinations of things that have really occurred. Also downstream, I mean, we fit in, if you really look at a plasma gasification or plasma gasifier, it would look just like any other power plant with a plasma gasifier instead of a coal-fired boiler, for instance. We fit into a larger structure that still has to have a steam or a gas turbine to generate power. It still has to have gas cleanup. It has a feed handling system. So we're a component in a larger power facility, for instance.
Okay. Yes, good morning. I run a company called Enviro Systems Canada. We convert organic waste into two value-added products, a fertilizer and a solid fuel pellet that's got half the energy value of coal. We've got 5 plants in Canada now. But in spite of doing the right thing and using waste as a raw material to produce a value-added product, we still get looked at by the regulators as a waste management company. And I'm wondering what the thoughts are of the members of the panel, less so by the City of Toronto and our customers, I must admit. It seems to be more at the provincial and federal level. But what are the thoughts of the panel members on how we can change the mentality and the thought process of the policymakers to take a look at this business as a true business producing a product as opposed to somebody being in the waste business?
This is a branding question, eh, Jeff?
I'll let everyone else first.
Yeah, I don't know if I got much to say on that. I probably don't really have a lot of experience yet in terms of dealing with regulators yet. That's not completely true. We've certainly, we're involved in getting sort of environmental technology verification process that goes on in Canada and in the U.S. To me, it sounds like you almost have to sort of map what you're doing onto this hierarchy of, as Jeff sort of said, the hierarchy that the ministry's laid out and say, here's where I fit and make your case. I mean, to me, that's certainly the tack we've taken when we've had conversations with different regulatory bodies. But again, I haven't had a lengthy experience with dealing with this yet, so yet to find that out.
No, I think that makes a lot of sense, Alan. I think, again, as soon as you cross below that line into disposal, you're then into a full environmental assessment process. If you stay above the line, then you're into a much more streamlined process. And I think that is the intent of the ministry, is to make it as streamlined as possible for diversion systems. The other thing we often do is we have an existing permit at our transfer stations. We have an existing permit at our landfill, for example. So if we can tuck an additional facility into one of those existing C of A's, then it's a relatively minor, compared to a greenfield site, a relatively minor change to an existing permit which also allows for a much quicker approval process.
Sounds to me like it's a branding question. You want the materials to be seen as raw material, as a supply.
And not attempting to defend the ministry, but for example, there have been a number of green bin processing facilities that have had significant odor issues. So, and other impacts on local communities. So I think from the local environment ministry perspective, whether the feedstock is ultimately producing a product that's diverted or not, it's still potential environmental local impact is what they're concerned about.
Yes.
Yeah, I just have a question for Mr. Fish. You were mentioning how before that you're saying that your plasma gasification technology is, I believe you said it's more cleaner and more efficient than traditional incineration technology. I just want to know if maybe you might be able to elaborate on that a little more for me.
Good question. It's typically, if you were to look at like nitrous oxide, let's say sulfur oxide levels, or even mercury, three kind of critical points or content issues within regard to incineration. Plasma would, on average, reduce those from 50 to probably 90% more efficiently. That comes through the heat process. Again, typical incinerators, somewhere from 700 to probably 1,000 degrees C would be the operating temperatures. The ability to break down a number of the negative constituents, the toxins, dioxins, furans, none of those things really start to occur until the temperatures are starting to exceed 1,100 degrees C. So it really becomes a temperature function for us, is where that efficiency comes from. These things can only be broken down so far. There are gas cleanup systems on the back end that are still scrubbing the syngas down to remove other elements as well. So because again, if we're going into power, for instance, and feeding the syngas, which synthesis gas is a lower value natural gas type product. It needs to be clean. Gas turbines are pretty cranky about getting dirty gas streams. So it's part of the process.
Yes, sir.
In terms of plastics and polymers, I just don't know to what extent discarded tires fall within the realm of solid waste. There are some companies in the States that pulverize solid waste or plastics and mix them with asphalt and then spread them on roads. I don't know to what extent you guys are familiar with that technology. And I would like to know whether it's feasible in Canada.
Tyler, do you want to take it?
We do right now exclusively look at only plastic as a polymer, do not deal with any other polymers which are like rubber polymers. Do not touch that. So look, I do not as a company, for us, we are not looking at anything other than let's say LDPE as a polyethylene polymers or so. At best, we are also looking at putting something on polypropylene, but we're not. So we are doing continuously R&D maybe, and hopefully we can expand to other polymers, be it rubber polymers or be it plastic, other kind of plastic polymers like polystyrene. But so far we are focused only on LDPE, HDPE, and LLDPE as yet. So I don't know how to comment on that.
I think you mentioned tires as well. So from a rubber perspective, I mentioned earlier that the brand owners of the products that go in the blue box pay half of our cost for blue box. On the tire side, the tire fee that you pay when you purchase new tires actually pays for a program that pays for 100% of our cost when we manage tires from residents and from commercial operations. So all those tires actually do get recycled. Generally into non-energy uses again, and certainly one of those areas that's being explored is tire content in asphalt.
Good morning, gentlemen. David Rosen from RBC's Cleantech Banking Group. My question is for Jeff. Jeff, I'm wondering, has the city gone back into existing landfills to process any of the waste that's there so that we can essentially claim back some of the space and use it for better use in the future?
Yeah, so what you're referring to is sort of often called landfill mining, which is a technique where you would go in and generally you're mining for two reasons. One, when you landfill, you're putting a daily cover of dirt over the garbage each day. And when you landfill mine, you can basically go back in and sift out that dirt, which then creates new space in the landfill. The alternative, the other part of landfill mining can be going in and actually trying to recover metals and other material. Putting it simply, I think we've got enough challenge with the daily flow of material that we are attempting to manage. And there's also a lot of challenges with opening up closed landfills, odor, and et cetera, et cetera. So simple answer, no, we have really not explored that to any great extent. Our focus is on getting to 70% diversion.
And just one follow-up question. Jeff, I imagine that you're approached by a plethora of companies that all fill part of a solution, a grand solution. And to the rest of the panelists, would it help you to be presented with kind of a combination solution where, companies kind of bind together and say, City of Toronto, here is a comprehensive solution looking at a large number of the aspects that you need, instead of having to have Jeff and his team sort through everything and try and find the little pieces and knitting them all together?
So first of all, from a technology standpoint, I should mention that we do keep quite an extensive database of all, you're right, we are approached by many, many technology companies. So we welcome that information. We have an extensive database such that when we are ready to go out for a competitive bid, we can contact those companies and say we're about to go out. And we're certainly open to just unsolicited proposals and concepts. And you're right, we've generally been in a situation where we as a city have determined the sort of master plan of how we want to go with input from our citizen groups, et cetera. And then we buy the pieces generally one by one. But I think we're open to all approaches.
One more in the middle. Oh, sorry.
My question is for Richard. Can you please give a bit of detail on how syngas compares to other gases when it's burned, the emissions that would come off of the burning of syngas compared to other gases? Thank you.
Yeah, I mean, it's going to basically look like a natural gas. So there would be a carbon monoxide or a carbon dioxide emission, from it if it's combusted. So, it's going to, from a heat value standpoint, if you looked at, natural gas that you have in your home today, would be roughly a half to a third the value of that, but it would, have similar characteristics.
I think there was one more in the middle, and that's probably all we got time for. Yes, sir. You don't have a microphone, but it's on its way. To your left.
Thank you. I'd like to commend City of Toronto for their realistic approach to waste diversion. And based on the fact that I've seen their waste diversion projects going back 15, 20 years, 2000 they said they would divert 100%, which is at that time we said was unrealistic. For those who participated in that conference, 50% was reasonable. 70% in a few years is even more reasonable. What I'd like to ask is, the waste diversion that Toronto's going through has hit a couple of bumps. One being, what has happened with Unical's demise and the fact that they were taking all the waste glass. Where is this going now?
We have, you're right, Unical was a contractor to us that took our mixed broken glass.
Yeah, through Stewardship Ontario.
Exactly. So that company unfortunately did move into receivership. We have been, I shouldn't say lucky enough, because due to the hard work of our staff, we've been able to find an alternative. The material, unfortunately, is now leaving the province, going to Quebec.
But to be the same company?
To a similar technology, yes. And basically, at that facility, they clean the glass, they then sort it into colors using really interesting optical sorting technology. Mm-hmm. And ultimately, it goes into a whole range of products such as beads and paint and all kinds of interesting products. So the good news is that material is still moving.
To go to Quebec?
Excuse me, I'm sorry.
Is there an excessive tipping fee to ship it to Quebec?
It's more that you're right, our net value is slightly lower because of the additional transportation cost.
Now, does that get added back into your net costs of recycling? So
ultimately, if you think of it this way, if it's costing us an additional $5 a ton to go to Quebec, we're on the hook for 50% of that because 50% is funded by the stewards. So yes, but the other thing is when you look at our commodity values, we see order of magnitude swings in value of product, of plastics in particular, paper. So we've just come out of probably the deepest trough in 20 years of commodity value prices. Our basket of good went down to about $50 a ton on average. And I mentioned we're at about $130 right now. So in the overall scheme of things, the glass prices may have $1 or $2 impact on our basket of goods, but it's not going to make or break us.
Okay. Is it true that about 50% of what goes through a MRF comes out the back door in that waste commodity?
No, that is not true. Typical residual rates at a MRF would be in the 10 to 15% range. But I should also point out that one thing we are absolute sticklers for is that when we present our waste diversion numbers, they are net of any residue that is pulled out of the system. So if we collect 100 tons of blue box material and we lose 15 tons through the process because residents have given us material that's unacceptable or just small bits of paper or whatever lost in the system, we only report the 85 tons actually going to market.
Yeah. And the majority of the revenue that you're getting through the system is through the diversion of aluminum?
Aluminum is a major driver. Aluminum, although it's a small percent of the basket of goods, is worth around $2,000 per ton. So you can imagine even at 2 or 3% of the weighted average of the basket of goods is going to drive a significant part of that index.
Right. Thank you.
Okay, we're heading towards 9:30, so that's the time we like to wrap up. So I'm going to ask Sid Paquette of our partner Deloitte to come up and thank our panelists.
Thanks, Rick. So while not necessarily a sexy topic, this topic should certainly be on top of mind for most Canadians given the amount of waste that we produce each year. And I think we only need to go back to the summer of '09 when we had the big garbage strike to realize how unsexy it is to have garbage and waste strewn throughout our city. In wrapping up, I'd like to thank each of the panelists. In addition, I would like to thank all of the folks from Mars, Ogilvy, and Renault who've worked very hard to put this event together. Finally, I'd like to thank each of you for taking the time out of your day today to join us today. Hopefully you found this as enlightening as I did. As a reminder, we have our next Cleantech in Canada session is going to be about mid-May, so look for that invite forthcoming. Thank you.